Hey guys, this is Mrs. Rooker, and I'm going to be doing 6-4A and B with you, which is primarily on roses. So go ahead and pause the video and do those first three review problems, and then when you unpause, I'll put the answers up. Alright, so here are the answers. The first one is a circle, and I used this to help get that answer. The second one is a line, but I replaced x with r cosine theta. And then the last one, that right there, is a polar equation for a circle with diameter of 8. All right, next section, label each as a line, circle, cardioid, or a limacon. So number 4, so we could, if we wanted to, convert some of these to rectangular, but hopefully at this point you recognize if r is 7, so we've got a radius of 7, that's just going to give us a circle. Number 5, if I have r equals, if something's written in the form of r equals a plus or minus a sine theta, or r plus or minus, r equals a plus or minus a cosine theta, that's just going to be a cardioid. All right, and then the next one, this looks similar to that, except it's not the same a value. We've got r equals a plus or minus b sine theta, or r equals a plus or minus b cosine theta. That's not going to be a cardioid. That's going to be a limacon. And because of the fact that a is less than b, the a value is less than the b value, it's going to be a loop. That's how you know it's a limacon loop. All right, the next one we have theta equals, and then just an angle measure. So if you think about your unit circle, now pi over 8 is not one of the angles that we're used to on our unit circle. It's going to be obviously a little less than pi over 6 might be like here. Pi over 8 would be like here. But then you could also have negative pi over 8. Whoops, I extended that the wrong way. But that's just going to be a straight line. Same with r cosine theta. Remember, r cosine theta is just the same as y. So this is just like y equals 9, which is a line. And then the final one is another one that's written in this form, except not cosine, it's sine. It's really this form. Because even though you can't see it, there's a 1 in front of the cosine, so those numbers are the same, so it's going to be a cardioid, which is just a more specific type of limacon. All right, moving on. If you have any questions on that, make sure to ask your teacher in class. So the goal for today is to graph equations in polar form. We're going to focus mostly on roses today. Oh, and I forgot the very first one we do is a spiral. In order to graph spirals, you must use radians. We're going to be in radians most of the time. Spirals are going to be written in this form. So if you see anything that's r equals number theta, that is going to be a spiral. The sign of m determines where the spiral begins. The direction of the spiral is always counterclockwise. Graph each spiral on the same polar plane using 2 colors. Use a graphing calculator and a table to get the decimal values to the nearest tenth. I do this the first time, I'm just going to make my own table, and then I'll show how to do it in the graphing calculator as well. I'm just going to start plugging in points like 0. start with 0. If r equals theta, then theta must also be 0. The next thing I might plug in would be, I don't know, pi over 6 or pi over 4. I think I'll do pi over 4. And then I want a decimal value. I don't want to leave it in pi over 4 for theta. So I'm going to do, in my calculator, pi, got to turn it on first, pi over 4 gives me 0.78. I'm going to round to the nearest tenth, so 0.8. And then just keep going. I think the next one I'll do is pi over 2. So we'll do pi divided by 2, which is 1.6. Should make sense because that's twice as much as the previous one. And then I'm just going to pause the video and kind of fill out the table so I'm not wasting your time. Alright, so what I've got here is a bunch of different values that I plugged into my calculator, and that's going to kind of give me a nice view of what my graph is going to look like. So I'm going to have my first point at 0, 0. And then my next point is going to be at, the angle is going to be just realized I had these backwards. The angle should have been here, and r should have been there. So the angle is 0, and the radius is 0. And then when the angle is pi over 4, the radius is going to be 0.8. So I go over to pi over 4, and 0.8 is going to be just less than 1. I should be doing this all in red. My next point is going to be the angle is going to be pi over 2, and the radius is going to be 1.6. So that's out here, just past 1.5. And then the angle 3 pi over 4, the radius is going to be 2.4. So that's 2.4 is going to be somewhere about there. And then pi 3.1. So pi is over here, 3.1. And then just keep graphing, 5 pi over 4 and 3.9. So 5 pi over 4, 3.9 is going to be about there. 3 pi over 2 is straight down, and it's going to be 4.7. So 4.7, somewhere in there. And then I skipped ahead a little bit, and I went all the way to 2 pi. I got a little lazy, and I didn't do 7 pi over 4. So all the way back over at 2 pi, I'm going to be at 6.3. So 6.3. So it looks like this. And now that we've done that one, we will move on and do r equals negative theta. So I'm not going to take the time to actually draw out a full table for everything. But r is just going to be negative of whatever theta was. So I'm going to go back to my old table and just take theta, or take what r was and make everything negative. And then we're going to graph those in blue. So, oops, that got erased. So pi over 4 negative 8.8 is going to be, we're going to go on to pi over 4, but we're not going to go in that direction. We're going to go in the opposite direction, 0.8. Still starting at 0. I forgot to write 0, 0 with blue. All right, and then pi over 2 would be right here, but we're not going that direction. We're going the opposite direction to negative 1.6. And then 3 pi over 4 would be over here, but we're not going over there. We're going the opposite direction, 2.4. So 2.4. And then keep that going all the way around. So I go over to pi, and then the opposite direction, 3.14, 1, 2, 3. 5 pi over 4, and then backward 3.9. 1, 2, 3.9. 3 pi over 2, and then backward 4.7. 1, 2, 3, 4.7. And then the last one I'm going to do is go to 2 pi, but then go backward. 6.3 is going to take us over here. So this is what my spiral ends up looking like. All right, so moving on, we're going to focus the rest of the time on roses. So roses are graphs with 3 or more petals, and they will look like flowers. Explore these on the calculator to figure out the rule for the number of petals. All right, so to do this, I will show you how to do it on your calculator, but this isn't something that you'll be allowed to use your calculator every time. So you need to learn how to do this without your calculator. When we do this in the calculator, we need to make sure we're in polar and not rectangular. You can do that by going to mode. Once you've done that, we just type 6 sine 2, and then the X button is now your theta button if you're in polar. And then we graph, and we get to see this pretty rose that has 4 petals. So that one had 4. And then we'll graph the next one. If you want, you can try graphing this on your own, see how it works. 5 cosine 3 theta. Let's see what that looks like. Oops, graph. And that gives me just 3 petals. Next one, R, 4 sine 5 theta. One, 2, 3, 4, 5 petals. And then the last one is 2 cosine 4 theta. And this one gives me a bunch. So I'm going to zoom in so I can see better when you zoom in. Remember, click enter twice so it actually zooms in. All right, let's count these. 1, 2, 3, 4, 5, 6, 7, 8. So 8 petals there. Now there is no great, pretty way of just looking and knowing how many petals you're going to have. So we're going to read on and figure out how many petals we'll have. In cosine roses. So when we have cosine will always have horizontal symmetry, and there will be at least 1 petal along theta equals 0. So always 1 petal along the pole. So either over here or over there when we're talking cosine. Sine, we will not have 1 on the pole or on the axis. Since cosine of 0 equals 1, then the maximum or minimum will occur at theta equals 0. This is where you will always have the tip of 1 petal. Then the petals are spread evenly around the pole, and you are going to add, if n is even, you add pi over n. If n is odd, you add 2 pi over n. And that helps to determine where each tip of the petal will be. And then you'll basically just see how many petals will fit in all the way around the circle. So that might be a little bit confusing. So hopefully these first examples will help to ease the confusion. I want to make sure you have the formula. I think you got this earlier, but these should all be in the form of R equals A cosine n theta. So if you look at this example here, n is 2. Which is even, and the A value is 5. That's going to determine how far out the tips will reach. So for cosine, if this is positive, the first tip is going to be over here on this right side, and it's going to go all the way out to 5. So 1, 2, 3, 4, 5. And then from there, we need to figure out where the other petal tips will be. They'll also reach out to 5, but we don't know how far they're going to be spaced around the circle. But I know that n is an even number, so I've got an even n there. So to find where my next petal tip will be, I'm going to do pi over n, so pi over 2. So I'm going to add pi over 2 to where I started. So my next petal tip will be over at pi over 2. It's also going to have a radius of 5. So that's where my second petal tip ended up. And then I do the same thing all the way around the circle. So I add another pi over 2. That's going to take me over here to pi. It still reaches out to 5. And then I add another pi over 2. That's going to take me to 3 pi over 2, which is down here. And then if I added another pi over 2, it's going to take me back to where I started. So I am going to have 4 petals because I have 4 petal tips there. The next thing I need to do is to draw some asymptotes. I'm going to have asymptotes between each petal to kind of guide and show me how far apart or how wide, I guess, each petal is going to be. So to find the asymptotes, or dashed lines, whatever you want to call them. Dashed. You are going to start at pi over 2n, then add pi over n for the rest. So pi over 2n. Well, we know that n is 2, so this is going to be pi over 2 times 2, which is going to be pi over 4. So my first asymptote or dashed line is going to be at pi over 4. Oops. And then to find the other ones from there, I'm going to add pi over 2. So if I add pi over 2 to that, that's going to be a quarter of the way around the circle, so that's going to take me here. Add another pi over 2, that's another quarter of the way around the circle. Wow, that was a bad dashed line, sorry. And then add another pi over 2, it takes me another quarter of the way around the circle, so I end up there. So those little blue lines are going to be asymptotes, or lines that the graph or the petals are going to get close to but not touch. So now I just sketch my petals, make sure they don't actually touch the blue lines. Alright, and that's what my graph should look like. Keep in mind, I didn't draw them this way, but these all should meet at the pole there at the center. They're all connected, all those petals are. Alright, so let's move on to the next one. The next one has an odd n value, and it's also got a negative in front of cosine. So since it's negative in front of cosine, I'm not going to be starting at 0, 6. I'm going to be over here at 0, negative 6. 1, 2, 3, 4, 5, 6. So that's going to be the first tip of the first petal. And then, because n is odd, n is 3, I'm going to have to use this formula here. Oh, my computer's glitching out. I apologize, guys. Alright, I'm going to use that formula there. 2 pi over n. So it's going to be 2 pi over 3 is the amount that I add from my starting petal. So I need to add 2 pi over 3 from my starting petal, which is over here at pi. So I have pi, and I need to add 2 pi over 3. Well, I want common denominators. Remember, pi would be the same as 3 pi over 3. So if I add those together, I'm going to end up at 5 pi over 3. So that's going to be where the tip of my next petal is going to be. So I need to add that same amount, or really I think it might be easiest to just subtract from pi to kind of go the other way around. So I'm going to do 3 pi over 3 minus 2 pi over 3, just to kind of figure out where it would be going the other direction, and that's going to leave me at pi over 3. So that's where my tip of my other petal would be, and you can probably tell those are equidistant from each other. So if I were to have gone the other direction, I would have ended up at the same point. So I only end up with 3 petals there, which is totally fine. And the next thing I need to do is find the asymptotes. Just like with the previous problem, to find the dashed lines, to find the dashed lines, I start at the same spot, at pi over 2n. But then I'm going to add not pi over n, because that's what I did when it was even. I am instead going to add 2 pi over n, because it's odd. So I start at pi over 2n, so in that case that's going to be pi over 2 times n, which is 3. So pi over 6 is going to be my first dashed line. And then from there I'm supposed to add 2 pi over n, so that's going to be plus 2 pi over n, which is 3. I need common denominators, so this would be, if I multiply top and bottom, this would be 4 pi over 6 plus pi over 6 takes me to 5 pi over 6 will be my first, or I guess my next line. And then if I take 5 pi over 6 and I add another 2 pi over 3 to it, which again, I can get common denominators and call that 4 pi over 6. Add those together, I get 9 pi over 6, which reduces to 3 pi over 2. So that will be my last dashed line, because if I were to add 3 pi over 2 again, I would just be back where we started. So I'm going to use those to kind of guide where my petals are going to go. So the petals are going to look like this. They are not going to touch those asymptotes, or those dashed lines. Alright. That is it for this video. Big things to remember. If something is written in this form, or in the same form but sign, we're going to do that tomorrow. If it's written in that form, it's going to be a rows. And the formula you're going to need to use to find the number of petals is pi over n if you have an even n value, and 2 pi over n if you have an odd n value. And then you're going to use that information to also find the dashed lines. All right, that is it. Thank you guys. Have a good one.